We kick off then. Thanks for coming along to this second session. This is a workshop / talk about deploying Prow. And essentially what I've done over the past couple of weeks is scripted up a manual deployment of Prow. And what Prow is it's the continuous integration tool used on the Kubernetes project. And it's also used on a few other projects like Istio and one or two others as well. So in terms of how Prow works, sort of at an architectural level, basically Prow leverages GitHub Actions in order to interact with pull requests on GitHub, and Prow orchestrates the running of tests and the checking of commits into the Kubernetes project. So the starting point for deploying Prow is a document called Getting Started, and that document, which I think I have here, so this document has come out of the SIG testing group, their repo. Their repo is test infra, and in putting together this talk and putting together this little bit of automation that I've done in order to deploy Prow, this was my starting point and my key reference material. This document talks about deploying and installing Prow from the point of view of serving the needs of the Kubernetes project. It's generic, but it is obviously cloud-based and talks about setting up things in the cloud. And in this bit of scripting that I've done, I've attempted to deploy Prow on my local dev machine and hook it up to a GitHub repo that I've set up myself, which is just a fork of Kubernetes. So, as we go through this document, basically the instructions here talk about setting up a GitHub bot account, and basically that's the other thing that this document will go through is using a tool called Tackle in order to deploy Prow. And in what I've put together in personal Prow is I've not used Tackle, and I'll go through what I've done to deploy it. And essentially, in a nutshell, I've written this bash script that will allow you to deploy Prow locally. Now, in going on in doing this work to get this deployed locally, I'm very much a beginner at Kubernetes and very much new to the community. And the reason that I went down this path to figure out how to deploy Prow, there was a couple of reasons. It's a useful way to learn about Kubernetes if you're a beginner, insofar as that it's a substantial application. It's talking during the break. It's easy to look at a sort of a hello world type tutorial, but if at the end of working through this, you can you're deploying a microservices based application that's written in Go, that's cluster deployable. So in going through this, you will, if you're new to Kubernetes, you'll learn a lot about it. So that was a useful thing for me. And then the overall reason that I wanted to do this was because in my first pull request that I submitted to Kubernetes, I made what I thought was a very, very small change to 80 files in the hack directory where there's a load of bash scripts. And that pull request was met with a sort of a mixture of, how to put this? It wasn't a great first thing to do for your first pull request to an open source project. And what had happened was the change that I had made was to turn off or to reinstate a rule used by a tool called shell check. And if you don't know shell check is a tool that will statically analyze bash scripts and warn you if you're doing something unsafe or unsavory or potentially risky. And one of the challenges that shell check has as a tool that checks for problems in bash is that if you dynamically source another bash script, and if the path to that other bash script that you're sourcing contains a variable, then shell check cannot evaluate that and therefore cannot follow the link. And there's a little, there is a way that you can say to shell check, okay, even though this path to this file is dynamic, you can put a hard-coded version of the path in a comment to tell shell check, you can follow this to get at this file and check it. Across 80 bash files, anytime another bash file was sourced from a bash file, I went and I put in this special comment to tell shell check where to look for the script. And when I submitted the pull request, all of the tests were run by the Kubernetes Prow instance, and there was a few failing tests, and it generated a lot of chatter and talk, and really I feel that it wasted people's time. And what motivated me to learn how to deploy Prow was to say, well, how can I replicate that pull request experience privately in order to give myself some assurance that the test will run successfully and so on. So in some respects, this may not be a great idea because the resources that you'd need on bare metal, you may not have those resources, and I don't yet know what jobs I could run on a decently spec'd machine. But from the point of view of deploying Prow and automating that deployment, if you were to look at both the code that I've presented here, and even though it has a few rough edges and there's improvements that could be made to it, if you put this code beside the getting started .md file in test infra, it'll act as a good guide to work through doing your own Prow deployment. So, so does anyone have any questions so far? If you don't, that's okay. I'll move on. So I'll have a little. There's a few things that I've touched off in deploying Prow to make this deployment easier. So when I developed this at home, a lot of the tools that I'm using, like YTT and CAP and KWT, I had those installed. And when I got this new laptop and installed Ubuntu on it, the script, I essentially had a load of assumptions about my environment. So I've attempted, and I've done this for most of the tools, I've attempted to check to see if they exist and install them if they don't. So if I was to, I'm trying to think the best way to start this out is if I just do /apply. Okay, so I have two functions here. I'll make these a bit bigger. Can everyone read that? Is that okay? Yeah, it actually looks better there. Okay, so I have so the kubectl deploy Prow function essentially is doing a kubectl apply of a starter YAML file that is present in the test infra repo. So this file here essentially is the starting point from where you can set up your Prow instance. In terms of configuring that configuration, I've used a tool called YTT, and that's a YAML text template engine. And I've only done a small thing with YTT, but I think it's just worth showing what I've done. Let's to jump out of this. Okay. So one of the steps that I have to carry out here, and I'll just refer to it here in the Getting Started documentation, is when there's specific images that need to be downloaded and need to be run, and they have specific tags, and you can see these tags here. And I think based on the release cycle of Prow, these get updated, and I'm kind of in an inception situation insofar as I have to deploy the thing to run the command that I have at the moment in order to find out what this is. So my solution here isn't fully complete, but essentially what I've done is values. Personal Prow. Okay. So quite simply, using YTT, we have a file here called values, and so in my script I generate this file. So I use a kubectl command to find out what this image tag should be, and this is the file that I generate, and I'll just go to I will do config. Oh yeah. Okay. So so in this YAML file here, so the way YTT works is it uses an annotated comment in order to introduce some code, and the code that it introduces is a Pythonic language, I think called Skylark, and it's fairly straightforward insofar as hash @ introduces this code. This is a string, and we can concatenate data.values.prow image, which we have over here, to basically make that correct for the deployment that we have at the moment. So in terms of making this work, we need, on line 1 there, I have the hash @ load @YTT data, so that pulls in the module that provides this data substitution. The only other thing that you then need to do, because we're using comments to introduce YTT-based code, normal comments need to have an exclamation mark appended to the hash, so that YTT knows to ignore those. So in the script, then I have I run YTT in order to affect that change, and page back in there /YTT. So so the first thing I do before I carry out the deployment is I want to actually validate the YAML that I have. So check config is an application that comes from test infra, and it's in the test infra repo, and check config will review and warn of any problems with the YAML that I have. But in order to generate that YAML, when I do my YTT there and that -f, that processes all of the YAML in the current directory, and then I send that to the configured directory there, and essentially that does that templating. So I'll actually kick this script off so we can see it run, and as I do that, we can speak to it. So this is what it looks like when the script is running. So you see that those initial 2 blocks of JSON are the report offered by check config. it normally comes out as a single block of text, and I just pipe that into JQ to make it a bit more legible. The next thing I do is start up kind, which gives us a cluster on the machine that we have here, and that takes the time to start up. So as a laptop, it's not a very grunty laptop. It has plenty of memory, but not a lot of CPU. So that takes the time. So as that's running, essentially what I'm doing is I'm taking the starter YAML from test infra and I'm applying that first. And then I'm applying that config that has some dynamism to it in terms of those images. And so if I was to do a get deployments, so that's what that looks like there now. So these are the components of Prow that work together to deliver the functionality that we get in Kubernetes. So deck is the user interface that presents what you see when you go to the Prow instance. Hook is the component that interacts with GitHub via Webhooks, and Horologum is for running periodic jobs. So horology is, I think, to do with clocks and stuff like that. So that's why that name is that. And then Tide, I think, does the merge once all the tests have passed and all of the that has worked out. Synchro and status reconciler are kind of new to me, and I'm not 100% sure what they are. Okay, so let's have a look here. Yeah, so it takes a while to come up, and I'm not sure why deck isn't coming up, but I'll soldier on. The second part in terms of configuring Prow to talk to GitHub is to set up the webhooks. Because I'm running on a machine that's not on the public internet, I use a tool called ngrok to SSH traffic back to my Prow instance. So I can show how that how I set that up. Start a fix. Okay. So this script here, again, leverages and uses tools and applications that are present in test infra, and the key one there is AddHook. So AddHook comes from test infra, and what it does is essentially set up the webhook on the repo that you're interested in interacting with. So I'll just give that a quick run, so you can see it in action. And if Wi-Fi is acting favorably for us, well, actually we won't need it for this. Okay, so this is the so ngrok gives us this user interface to indicate and just let us know. Basically, I'm trying to think here now. If I go off to GitHub, and you'll see that I've run this a few times today. So this is the GitHub repo that I'm interested in interacting with. If I go to settings on this, we can see that under webhooks, I'll have a few webhooks, they'll all be red. So if I was to let's go back. So just deleting these just to sort of demo that AddHook script. And okay. So if we reload that, we should see a new webhook. And so this URL is offered by ngrok, and if if Prow was up on my machine, it would reach back and interact. So that's how I wire up GitHub back to my instance there. So the fact that it's red indicates that we do have a problem, but and the error there is. This is a very useful way of seeing the interaction between GitHub and your instance there, and so the response that we receive is that HTML that's indicating that the ngrok is reporting, well, I'm trying to reach back to the instance that I want to talk to, but I'm having problems. So and I presume is returning possibly a 500 or an error message in that range. So. I'll just go back to here, back to here, back to here. Okay, so we can see that the cluster has come up. Now, the final piece of the puzzle for me, because I'm new to Kubernetes, I made use of a tool called KWT, which is the Kubernetes Workstation tool. I think that's what that stands for, and that allows me to set up ingress quickly and easily, but sadly, although it was working this morning, it's not working now. But I'll just see, because it's failing. There's an intermittent nature to the failure here. I'll just give it a quick run now, just in case it might work. Oh yeah. Okay. So when I kick that off, essentially this should expose the deck application so that it's reachable from outside the cluster. Now, unfortunately, for some reason it doesn't appear to be working here, and I'm not 100% sure why that is. So I've not had a chance to troubleshoot why this is the case. But if it comes up, what we would end up seeing is deck through this URL. But sadly, the demo gods are not with me today. So so that's pretty much it. In terms of where all this code resides, it's here. The code as it stands right now has some hard coding in relation to which GitHub user, it's me, my user account, and a specific repo that I've set up, and I've put them into variables, but I've not made them completely configurable. So if anyone wanted to contribute a pull request, I'd be happy to take it. But essentially, they're the steps to run this locally. So that's what I have. So that's, I suppose, the end of the presentation part. Does anyone have any questions? Okay. Well, yeah. If there's no questions, then I'm happy to leave it there, and I'm happy to talk to anyone afterwards about it. And yeah, that's it. Thanks for coming. Cheers. Oh, there's it. There we go. Oh, hey, it works. Okay. So, quick addendum. So once KWT comes up, and I don't know if it's local networking issues that's causing problems there, and we're just not 100% sure. It could actually be the case. that was a quick and easy way for me to handle ingress. In terms of everything that I've done here, I'm not in a position of sufficient Kubernetes experience to say, yeah, this is definitely the way to do it. You know, so I would take any feedback, and in terms of I can only endorse what I've done for this very, very specific private, you know, underpowered use case. You know, so yeah. And obviously the next step is to basically see what jobs I can get running locally. So that'd be maybe Contribex Amsterdam. Okay. All right then. Thanks, guys.